This based upon words spoken after any part of the spacecraft, in this case the lunar module, touched the surface, and also tell me who said them. Go to planetary.org/radio contest.
You have until the 23rd. That's March 23 at 8 a.m. Pacific time. And we are continuing in this giveaway of a whole series of prizes from Chop Shop Store, chopshopstore.com, I should say. This time, the poster is Juno over Jupiter. It is absolutely gorgeous. I would be very happy to have this on my wall. It is the spacecraft that is still doing such good work out there over our queen of planets in this solar system. Looking down on that amazing surface, it's a 4-color screen print, 20 by 36 inch, and it will go to the winner this time around.
What surface, Matt? Isn't it Juno at Jupiter? I mean, they look at the moons, but I assume the poster is Jupiter? Yeah,
it is. Is the swirling cloud tops. I'm not expecting to go down to the metallic hydrogen here.
Metal! Metallic hydrogen, definitely the name of one of my bands. All right, everybody, go out there, look up in the night sky, and think about walking through the woods and listening to Matt's soothing voice talking about planets. Thank you, and good night.
Hey, Sam, we're going to join you there on that walk sometime. It may not be quite as soothing when you have the chief scientist of the Planetary Society, Bruce Betts, and me along for the walk, but hopefully it'll be entertaining.
Oh, look at that over there. Oh, look at that. Oh, look at that.
Where'd Sam go?
Uh-huh.
Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by its members who make all of our work possible. Want to step up and join them? planetary.org/join. Mark Hilverda and Ray Pauletta are our associate producers this week. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. Ad Astra.
Honorary Spock here. You're listening to Astronomy.fm, AFM radio, a most fascinating station.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You're listening to AFM radio on Astronomy.fm, around the world and beyond.
Arr. Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.fm.
The pirates are coming. The pirates are coming. The pirates are coming.
Arr! It's Space Pirate Radio time here on Astronomy.fm. It is 9 o'clock in the evening on Wednesday, March the 16th, 2022. And Daylight Savings Time, by the way. Don't forget. I see most of our crew is here on time, but if you forgot about us, don't forget that little difference of hour change that it was before. Universal Time puts us at, what was it? I think we're at 2 o'clock in the morning. Yeah, we're sprung forward. 2 o'clock in the morning. Yeah. Thursday, March the 17th, again, 2022. So we're live for the next hour. And, of course, we have to say hi to all of our crew in the chat lines.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Julie Tomei, and this evening I am joined by Dr. Elena Hyde.
Hello, hello.
Hi. We are broadcasting live from the Allan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, and that is Tuesday morning at 1 a.m. UT, because we are now in Daylight Savings Time. Dun, dun, dun. York Universe production works in concert with our online public viewing program, which is run by the Observatory team, and that runs between the hours of 9 p.m. and 10 p.m. local Toronto time. You can head over to observatory.info.yorku.ca and follow the links to OPV, that's online public viewing, to join that and join in the chat. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have any suggestions for future topics, you can send us an email at observe@yorku.ca. You can also contact us through the socials. We are at York Observatory on Twitter and Instagram, and you can also find us on Facebook at Allan I. Carswell OBS. All our programs are free, but if you would like to make a donation, we will not say no. Again, our website is observatory.info.yorku.ca. All right. Since we're just the two of us, we will try to monitor the chat room, but it might get a little tricky for us. We will do our best. And as always, I have not checked what the current weather is. Do you know what it is?
It is cloudy. It is unfortunately too cloudy to open the 1 meter tonight. So I do happen to know that our tried and trusty crew is showing some very lovely images over on OPV. So as Julie said, the website's up there. You can also go directly to YouTube and just search for York U Observatory, and they have some lovely images and chit chat. And I believe there's at least 3 or 4 of them on, so they should be able to say hi to you over there as well if you'd like.
Excellent.
Darn clouds, though.
Well, you know,
we used up all our clear weather last night, I think. But hopefully later on this week it will get better again. At least we are going into the springtime now, so less of that crazy cold white stuff floating around Toronto.
Yes. Most of it is gone from my front lawn. Thank goodness for that.
All right, so shall I start us off with a little bit of old news, I suppose? Old news before we get to the new news?
The old news before the new news? Yes, why not? Let's jump into that.
All right, so I have some super, super old news. So this week in history, as we like to say, if I go all the way back to about 2,700 years ago, this week in history, there was roughly a recorded sighting of the Lyrid meteor shower, 687 BC. This was actually recorded by the Chinese, and this Lyrid meteor shower is coming up soon, but it's interesting because it's just after the March equinox. So we are actually going to relate this back to this week in history. We had not just 2,700 years ago, but as far back as we can record, we did have the equinox. And so I thought, what a fun thing for this week in history. We have an event that is literally throughout history this week and actually yesterday. So if you were counting, that would have been Sunday, the 20th of March. We had, of course, the equinox, which means we in the Northern Hemisphere, in Toronto in particular, are leaving winter and we're going into the spring, and it's only going to get better off from here. So your closest call between equal day and equal night would have been yesterday, and now of course our days get longer, our nights get shorter, which is a little sad for those of us up at the telescope. But we do have, of course, less snow to deal with, which is a reward in and of itself. So I wanted to just go ahead and give a little call out for, in particular, this time of year and the March equinox, which we, could measure if you've got a sundial out or even a long stick will do it, actually. Catch the sun midday on Sunday, where it actually was very, very good weather. And we, right now, because, it is an interesting time of year to look up, and we're about to go into a global astronomy month, which I'm sure we'll talk about later on in April. We also have Venus at greatest elongation west, which means Venus is right now a lovely morning star, appearing sort of at its farthest distance from the sun. So I wanted to give a this week in history that was a little bit different, maybe going back quite a ways, and give a little call out to people looking forward to next month as well. Of course, look out for those Lyrids or Lyrid meteor showers. And it is really kind of a unique and fun time of year. So I thought that would be a retroactive sort of ancient history this week for all time, as far as we can tell. So as long as the Earth had, of course, a tilt to its axis. So sometime after that collision that formed the moon, I suppose. So that's basically my first item.
I love it. I always try to get my this week's to be something a little different. I don't want us to be repetitive. So this is fantastic.
Well, and it is something that does happen twice a year. So just as maybe a little reminder, if you're listening to this show for the first time, or maybe you haven't had a think about what the equinox is the sort of the even point of the year. There are two equinoxes every year, one in March and one in September. And this is when your daylight and your dark time are as equal as they can get for your position on Earth. So in the northern hemisphere, we're getting more sunlight. In the southern hemisphere, they're actually getting less sunlight. So they're going into fall. And this is, of course, because we have a tilt to our axis. So if our northern hemisphere is pointed more towards the sun, the southern hemisphere is pointed less towards the sun. And the seasons are reversed from north to south, or south to north, if you will. And we do have, of course, this year, 2022, it was Sunday, March 20th, I believe, around 11 a.m. Eastern time, something 3 p.m. UTC or so. And this is a really interesting little time of year to note, because, of course, where you see the sun on the equinox is going to depend on your latitude on Earth. So Earth's tilted at an angle of about 23.4 degrees, which is really, really fun, because that's what gives us our seasons. If our planet wasn't tilted, we wouldn't be having nearly so much fun right now, although maybe we wouldn't need daylight savings time.
Well, I mean, we won't get into a discussion about daylight savings time and its pros and cons, but the equinoxes and I always throw in the solstices with them, right? Those four special days in the year are we kind of, well, I mean, they kind of come and go. And certainly in certain cultures, have some special significance. But if we're thinking back to, 2,500 years ago, it feels like those days had even more significance.
Oh yeah, this was your calendar.
Now.
Yeah.
Absolutely.
It's if you wanted a really good calendar, before we had modern clocks and things, all you really had to do was make some windows that aligned with your equinox and solstice positions, right? Because that is where your sun will appear to set on the horizon, and we actually do see that in ancient calendars or standing stone star charts. So it's really really fun stuff, and it is something I think it's easy to take for granted sometimes. So I thought, let's use this as our this day in history. So
Yeah.
that's just my first one. I'm sure you have some as well.
Oh, absolutely. Have you visited many places that have this sort of like there's a window or a rock or a hole in a
Yeah,
place?
it's really interesting because I had not nearly as much as I would want to, but I did have the opportunity to do an archaeoastronomy research project when I was an undergraduate student, and we actually
Cool.
did stone star chart alignments, which were present in aerial photography in North America, and that's
Oh,
actually
nice.
it was sort of Vermont, Maine, and actually even possibly all the way up through Ontario. We didn't get enough aerial photography to finish mapping it, but it was really interesting. And ever since then, I've always been really interested about how these different calendars were constructed. Because of course you have lunar calendars, solar calendars, stellar calendars, lunistellar calendars, lunisolar calendars, and so
Yeah.
everybody created their own calendars based on their unique position on the earth. And it's really quite interesting because I moved to Canada from Australia, and there they have, of course, a really long history of Indigenous astronomy that's been fairly well documented back 30,000, 40,000 years. And the advanced nature of these calendars is not to be understated.
Oh, yeah, no, absolutely. I guess the first of these sites that I visited was in Tulum, in the Mayan Riviera.
Oh, wow.
Um, yeah, they they had like a building on the site that they referred to as the observatory. Of course, it didn't have a telescope like observatories today have, but it had windows at certain places that lined up with, you know, certain star positions or sun moon positions. And I've been to Stonehenge. These are, some of like the really like Stonehenge is almost like the most famous one, right? That and
Well,
like Chichen Itza. I haven't been to that one yet.
I think Stonehenge is probably the one of the most popularly printed. It really does capture the imagination. But yes, I haven't been myself. So were you able to go on the Equinox?
No, no, but it's cool to, the weird thing about Stonehenge was, like it's so talked about. You see so many pictures of it. Like I almost felt like it was overhyped going there. I was like, whatever, I'm going to Stonehenge. Like I've seen it in pictures. And we got there and I was like, this place is so awesome. Like I'm so glad I came. I'm so glad I didn't let I didn't let myself feel like I was like, I don't know, not too cool. Like I don't think I'm too cool for anything because I'm not cool. But like didn't let myself like psych myself out about going there. Um, because I'm not big on like crowds and whatever. But it was
Well,
really cool.
I will point out that I've never been to Stonehenge, but I did get an opportunity to drive by a full-size concrete replica of Stonehenge in I believe the U.S. state of Washington. I think it was. It was a long time ago. But if you map out the alignments that Stonehenge is supposed to be showing throughout the year, you actually can build your own in your backyard if you are so motivated. And some people have. I know there's at least one in the US, probably two. There's one in New Zealand. There's and I think a few other places as well. Maybe in Tasmania, if I'm remembering right. And then there's, of course, less accurate replicas, because if you try to align it such that it will show the same types of seasonal alignments that Stonehenge would have shown thousands of years ago, then you actually get, a reason why, of course, the stones are spaced as they are. It's really quite fun. I believe they even had a snow competition where they built a Stonehenge snow sculpture, and it sounds like something
fantastic.
that would happen in Canada, but I don't remember where it was. So,
well, I do know that there is a Carhenge in Nebraska.
Oh, okay, that's pretty good. So if you don't have enough snow, there's an alternative.
Build it out of cars.
Exactly. But yeah, the way the alignments are set, if you know how to read that calendar, it is very accurate, and it doesn't actually become inaccurate for thousands of years. So that's on par with our calendars now.
And I'm trying to remember a while back. I know it was Jesse Rogerson who did the talk. I can't remember where I saw him give the talk. Might have been for the RASC.
On
Can't remember. No, he probably mentioned Stonehenge as one of them, but about these sort of like archaeological, like ancient sites that were all like.
I know this talk. Okay, so I can actually do an advertisement for our Wednesday night teletubes in the middle of this.
Teletube.
Because we had Jesse Rogerson come on and give this talk as a guest speaker on one of our Wednesday night broadcasts online, which we do because of the pandemic. If you didn't know, this is normally what would go in the middle of the broadcast. We would tell you that every Wednesday night we do fabulous astronomy shows, and if it's clear, live imaging. And Jesse was on talking about this exact thing. And Stonehenge was one of the sites that he did mention. Of course, sort of showing how it does align up with various constellations, like, of course, the Pleiades is one that's used by everybody in the Northern Hemisphere because it's really, really popular. But not just the Pleiades, things like, bright star alignments and sun and moon alignments to map out all kinds of different calendar dates, not just equinoxes and solstices, but the cross quarter days, which are the half. It's halfway between an equinox and a solstice, if that makes sense. But yeah, they're really, really fun the way it's all worked out. And if you like geometry and relatively easy math, they're quite fun to play with. So I definitely recommend it. And it's actually a way you can date sites. So if it's an archaeological site, you can find the stellar alignment that would have been there and find out how far back you have to run the stars before they would correctly align at the seasons, because of course over thousands of years the stars do shift in their position. And actually, if you run the stars back for example, for Stonehenge, you'll actually find that the alignments are right about in the year about was it 3000 BC or something, so several thousand years ago. You actually have the correct alignments with Stonehenge for all the seasons, which is really cool. So you can actually do astronomical dating and all kinds of cool archaeoastronomy stuff with these things.
Yes. So
we're going
would recommend going to find that Teletube episode with Jesse because there were a bunch of sites that he mentioned that I had never even heard of.
Yes, absolutely. 10 out of 10, great episode by Jesse, and that is something you all can find on the channel. It's still there under the playlist for, I believe it's broadcasts.
Good name for the playlist. All right. So let's move on to our second piece of this week in history. So we're going to March 22nd, 1952. And this is a publication of Collier's Magazine. It was a special issue entitled Man Will Conquer Space Soon. It had a number of articles in it, and they were written by greats such as Werner von Braun, Willie Ley, Dr. Joseph Kaplan, Dr. Heinz Haber, Dr. Fred Whipple, and the articles included. Here are just some of the headlines from the articles. What are we waiting for? Crossing the last frontier. A station in space. The heavens open. This side of infinity. Can we survive space? Who owns the universe? The issue was followed up by other articles in the magazine over the next couple of years. And in case the names that I've mentioned don't mean anything to you, because, I mean, you may not have heard of everybody in the history of everything. Von Braun was a pioneer in rocket science and space technology. Ley was a science writer and historian of science who, before becoming a science writer, studied astronomy, physics, zoology, and paleontology. You know, like you do, study all the things. Dr. Whipple was an astronomer who worked at the Harvard College Observatory for, I believe, 70 years or something like that. Something.
Yeah, it was
crazy
a long
long.
time. I do recall this legend, as this is somebody who had a very long career. But good for him. Good for him.
Yeah, back in the day when you didn't change institutions and just stayed there and worked till you died, I guess.
Well, there's something to be said for being able to stay in one place. I have to say.
Hey, listen, I've been working at the same place for almost 15 years. I know.
Oh, well,
I have no plans going anywhere.
Well, that is one thing I'm very much looking forward to staying in one place here in Toronto. But yes.
Dr. Whipple was also the one who proposed the dirty snowball hypothesis of comets. Dr. Haber was a physicist and science writer. He was known for TV shows and books about physics and environmental subjects. So he was a popularizer of science. And Dr. Kaplan studied atmospheric phenomena and geophysics. He participated in the launch of the first Earth satellite. So I'm assuming that's Sputnik. Definitely not the moon. And get this, he warned of anthropogenic climate change in 1956. 56.
Yeah, well, by then it was known, right?
Imagine if we'd done something starting then.
Yeah, that would have been pretty good, actually. That would have been very smart of us as humans.
Yeah. Oh well. Something about the 50s that just like, I don't know. Titles like "Man will conquer space soon."
Yes. Yes. Well, and those old papers were are really quite nice to go back and read if you can, because it was an interesting time. I mean, we're in interesting times now, but in a way it does show we've kind of always been in interesting times. But the 50s were, yeah, there was definitely something going on there.
I'd be interested in going back and reading some of the stuff, because you could see like they're definitely thinking about, I mean, kind of the obvious things, right? Like, human survival in space and the final frontier and that. But like, who owns the universe? Like, you're looking at like, I guess more like law, like.
Yeah, space law, early thoughts on space law. Well, and I mean, even, for ever since there have been humans, we have been traveling around, going to other places, and how should we be treating those other places is an ongoing discussion because obviously
Indeed.
that doesn't always work out well. But I did find for the trivia lovers, there is an old paper from the 1800s, I believe, which was a paper on was it carbonic acid in the atmosphere, and 1896. There was a paper for the greenhouse effect on the influence of carbonic acid in the air upon the temperature of the ground. And it's by someone whose name is a little hard to pronounce, Svante Arrhenius, with an A. And so these ideas of chemicals in the atmosphere having other effects it's interesting to remember that this has been something that people have been thinking about, because of course we knew that you could mix chemicals together and they would do explosive things. So historical context is always really fun.
Oh yeah, absolutely. When I was a student at York, there was a panel talk that I went to, and I think it might have been a recording, like a live recording of Quirks and Quarks or something like that. And they were talking about what would happen if the aliens landed tomorrow. And they had a physicist, they had a lawyer, they had a science fiction writer, and the physicist was my favorite because he was just like, I would go and say hello and ask them what kind of music they listen to and what they do to party. I was like, yes.
That is exactly, a physicist would just literally walk up and say hi. Everyone else would be doing other stuff. Worrying about
the lawyer kept going on about the dissemination of information. It's just like,
yes. Well, I did ask an economist, and there is actually a reasonably good simulation of what might happen economically in a series of books called The Three Body Problem, without giving any spoilers on the book itself. So apparently, the economic impacts are also something to keep in mind. But yeah, I would just go say hi. That's it's the astronomer in me, I guess.
Hey, how's it going? What do you do for fun?
Yay! Hello.
Please don't take over our planet.
I'm so glad to meet you. This is awesome. But everybody has a different reaction, and that's fine. I think the interesting thing to think about is, as unlikely as something landing on our planet is, it is substantially more likely that we might, at some point, somehow, actually manage to detect a signal or a communication that would be alien radio, and they could be listening to our radio right now. Wouldn't that be awesome? And then what would we do? Would we try to contact them back? Would that be so, or would we just, start some sort of cool radio show based communication?
Oh, it would all depend on what we're getting.
Yeah, that's true. If they send an astronomy podcast back to us, I would be thrilled, though.
Yes. If we're getting astronomy podcasts from alien races, I'm down.
Yeah, that'd be awesome.
We're getting the equivalent to call-in shows.
Oh yeah, okay, maybe that wouldn't be.
No thanks.
Reality TV would be a little less. Let's hope for astronomy podcasts.
Yes.
So speaking of astronomy news, I suppose. Shall I do another one?
Absolutely. Let's move a day back and several years back as well.
Yeah, so we're hopping
centuries
around a little bit. I think I picked mine too old or something, because I go from the earliest point in time to only 1762. So it is going back in time quite a bit. Again, as I say, I do love the historical context. So in 1762, on March 21st, for as a astronomer sort of day, we have Nicolas Louis de la Caille, or I think I'm saying that right. Julie can tell me.
You did very well.
So he was an abbé, and he was a French astronomer and geodesist who named 14 out of the 88 constellations that are now part of the official IAU constellation list. So if you've ever thought the constellations weren't didn't have the most diverse set of names, so 14 out of the 88 actually just came from this one person. He had the name and he was making the maps, and so of course being picked up as a standard later. Well, actually, part of that started here. So with this particular French astronomer. So this is the day he passed away in 1762. He was only 49, but in the time that he had, he did quite a lot. So he actually spent a lot of time making astronomical maps, and he was one of the observational astronomers and geodesist. So he had that's a lot of geometry and sort of trigonometry for those of you who are interested. He followed Newton, and he developed a lot of ideas about celestial mechanics and the shape of Earth, and he spent a lot of time thinking about complex gravitational effects that might take place between different bodies. So what about between the Earth and the Moon, or between Jupiter and various other things? So he did a lot of observing from South Africa and the Cape of Good Hope, and he made the first ever telescopic sky survey in the Western style. So obviously there are other star maps predating this by quite a lot, but he did a lot of measuring of the paths of planets and made a modern, up-to-date sort of sky map in particular for navigation. And apparently he was really taken with some of the difficulties that sea voyages had in navigating around and having good maps. When you had those old boats and were trying to navigate your way from, the southern hemisphere to the northern hemisphere and back, for example, you can, having a really good star map would actually help you substantially. So he had a whole bunch of different astronomical things that he compiled. So he had a 2-year stay in South Africa where he did observations of about 10,000 stars. And this is when you were still going one by one with your stellar observations. You had to have, observing every night for over a year, and that's a tough go in any in any count. And he took note of various nebulous objects as he was going, and he made actually a list of 42 notable southern hemisphere nebulous objects. He was trying to get lunar and solar parallaxes, which of course would give distances in the solar system, using Mars as kind of an intermediary. And he did collaborate with Europe, and of course using things like the equinox and the solstices, you could actually say to someone in the northern hemisphere, make this observation at exactly the same time that I do in the southern hemisphere. And how do you exactly align two observations in the northern and southern hemisphere for date and time in the 1700s or in 1750 to be more exact? Well, you have to use certain days. So the equinox, I believe, was one of the days that he actually did use. And so to get parallax, he used, of course, the distance from Europe to South Africa. And the observations in Europe were carried out by Jerome Lalande, and he carried out the observations in South Africa, which is really cool. So while doing this, of course, you get an arc measurement to determine the radius of Earth. So he also got to confirm the size of Earth, which was well known by that point, but still, nice geodesic sort of astronomical observations, getting latitudes, and he actually found that not only was he able to find the size of Earth, that he found that the Earth was more flattened towards the South Pole. So a little bit of, we have a little bit of squishiness in our planet. It's not completely a perfect circle. And that is something that is carried out today. So we do now know that there is a bit of squishiness due to those squishy oceans that, of course, things tend to accumulate around the middle, not just, pandemic bounds, but actually a little bit of a squish towards the middle of Earth. So we did have all kinds of really cool stuff happening from Lacaille, and he calculated a table of eclipses that goes for 1,800 years, and he did this in the 1700s. So I believe his table is still valid. And he had made more observations and calculations and tabulations than most of his other colleagues combined, right? And the quality of his work was really, really, really good. The tables that he produced are still available, and you can actually get his Colem Australe, which is his map of the Southern Hemisphere. I believe it is on the Free Internet Archive. Really, really wonderfully done, and it's open source, obviously being printed in the 1700s. So if you get a chance to look at that, I highly recommend it. He did go back to Paris in 1754, and he did not have the greatest of health. So of course he did pass away, unfortunately, early, but his books and maps are still out there. And if you get a chance to look at them and you like old historical things, especially old historical things written in French, I highly recommend it. So I think I'll wrap up there. But yes, the top ones, I think I would have to call out his charting of over 10,000 stars and naming 14 of the constellations. And his catalogs, FYI, are still in common use for Southern Hemisphere stars. So that is, Nicolas Louis de Lacaille.
Well, now I finally know who to blame for all those really boring constellation names.
14 constellations. I was going to look it up. I have a feeling that he is the one that picked Telescopium as a southern constellation.
Yes,
but,
I have the list here.
Oh, you do? Yeah. So it's...
I
do. I see it. Yeah, so Telescopium was his, right? And that's... I mean, how can you blame an astronomer for naming a constellation Telescopium?
Okay, I can't blame him for that. But like Fornax?
Yeah, that was just a bad choice.
Right? Is a little silly. Like it's all like, if you look at them, they're all like lab equipment. It's like he was sitting at his table going, "What will I call this one?"
It's Fornax is Fornax is just Latin for furnace, right?
It's so like Bunsen burner.
Yeah, he's looking at his fireplace going, okay, so that's one. That's what an horologium. That's just a clock, right?
Yeah.
Right. So yes, we can blame him for some of these, but not Telescopium. Telescopium is allowed, and he does have a crater on the moon as well, named after him.
I mean, well deserved.
Absolutely. And lovely, lovely catalogs. If you do get a chance to get a copy of D'Astronomie, it is supposed to have some very nice drawings and tables in it.
Awesome. He also has an asteroid.
Oh, does he? Well, I'm a little jealous now. If it was just a moon crater, I wouldn't be as jealous, but an asteroid, well, gosh.
Well, if I ever discover an asteroid, I'll name it after you.
Oh, that's a big promise. I wouldn't make that without consulting more important people than me.
I mean, it's also pretty empty promise because I don't spend a lot of time looking for asteroids.
Fair enough. I'll tell you what, if we discover one through the 1 meter, which we actually might start looking for, you and me will consult on the name, and then we'll call it Telescopium 2 or something.
Sounds good. Speaking of things with fun names.
Oh, yes.
Our last This Week in History is on March 25th, 2002. And it was the launch of the Shenzhou 3. So Shenzhou, means Divine Vessel 3. It was the first Shenzhou spacecraft that could have carried human passengers. This was an uncrewed mission to test the systems that would eventually take the first taikonauts to space. So if you haven't clued in yet, this was the Chinese space program. It carried a dummy to simulate physiological signals from humans, including palpitations, pulse, breathing, eating, metabolism, and excretion. I'm a little bit interested as to how exactly this dummy worked, especially in that part.
Yeah, I don't know if I needed a map for that or anything. Just believe them. But they.
I'll take your word for it.
Yeah,
not sure how your dummy ate, digested, and excreted food. It carried 44 different experiments on board, including, imaging spectrograph, cloud sensor, radiation sensor, solar ultraviolet monitor, solar constant monitor, atmospheric composition detector, atmospheric density detector, multi-chamber space crystallization furnace, space protein crystal equipment, cell bioreactor, a solid matter tracking detector, and a microgravity gauge.
Wow. So it's like a it's basically like the Swiss Army detector of all the things.
Either that or it was like a Swiss Army lab.
Yeah, exactly.
These are all different pieces of equipment in one room. I don't know.
It's a tricorder.
It broadcasts.
No, okay, go ahead.
Maybe. It broadcasts video images of Earth as seen through one of the windows of the spacecraft and transmitted a recorded message to test the communications. The mission lasted 107 orbits and re-entered. The mission ended sometime in October, and the spacecraft re-entered in the atmosphere in November. And because I'm a word nerd, the etymology of the name. So Divine Vessel, it kind of has like a square brackets, in a text when you have like the square brackets to like show that there's a part missing or like implied. So it's like the Divine Vessel square brackets on the Heavenly River. And in classical Chinese, Heavenly River means the Milky Way.
Ah, so cool.
It's such a poetic name. I like it.
That is really, really nice. I have to say and the Chinese manned space program has been doing really well. They're now underway with their space station construction, having missed that collision not too long ago, but they seem to be doing really, really well in terms of their number of missions, and they've never had a fatality. What is it? It's been some large number of missions now, 18 missions or something. And the space station now has laboratories, and I believe they've got people up in there. So it's actually doing extremely well, and it's a little bit sad that we don't hear more about the China space program.
Yeah. I always like to try to include content about other space agencies and what they do, because we hear so much about NASA and ESA. But there's so much else. There's so much else happening.
Yeah, well, and there is literally an entire space station in orbit, which is doing extremely well. So I think it's the this program, the China manned space program. It's the Tiangong space station, and it's in low Earth orbit, but it's about 1/5 the size of the ISS at the moment, and it's got core modules. It's got crewed and uncrewed missions. I think there's 2 more modules coming on this year. And they're doing all kinds of great science up there. So yeah, keep an eye on that space too.
Indeed. All right. So look at us. We've gone on for so long. All right. If you're
too much fun.
Oh, good. We'll get our news segments in. If you're just tuning in, what took you so long? You're listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Head over to observatory.info.yorku.ca for chat, questions, content, etc. You can also find us on the socials, Twitter and Instagram at York Observatory. Tonight you're listening to myself, Julie, and Elena. We just wrapped up our This Week in History. And now we've got a couple of reminders. First of all, Happy Nowruz to any and all who were celebrating yesterday. And we did do a quick, a lengthier plug for Wednesday Teletube. But here's another reminder. Wednesday evenings, 7:30 Toronto time on YouTube. Go watch us. See some stuff.
York U Observatory on YouTube. And I believe this week we're planning on doing a special sort of solar system tour broadcast. So it should be pretty fun. Come on by. Now, I think we've got enough time for both of our news articles, but how about I do mine a bit first, because I really secretly want to talk about yours, Julie.
Yes, do yours. And I have a little thing to add to yours that I found when we were just about to go on air. So go.
Excellent. So in the news right now, you might have heard that there's a lot of moon landing work going on. And so I know we were saying we talk about NASA too much, but it is actually, there's a reason we're doing a lot. So NASA's Mega Moon rocket has actually gone off to the launch pad for the first time for testing. It has been, of course, 50 years since humans were on the moon. We do not have our Saturn V rockets anymore. This new space launch system is called SLS, which in the grand tradition of astronomy acronyms, SLS is Space Launch System, because we are bad at naming things, but it's actually now been tested. So this Mega Moon rocket is actually going to be more powerful than the old Saturn V's. It's going to be able to lift 24 metric tons. So it's going to be able to get large payloads off the ground. And this in conjunction with, of course, the SpaceX Starship, are going to be needed for the Artemis program. And so this is a really ambitious program. Actually, Artemis 1 is set to run a uncrewed dry run to the moon. So it's going to go around the moon uncrewed. Artemis 2 is going to have a 10-day mission carrying 4 astronauts and 1 Canadian around the moon. We know one of the astronauts will be Canadian because we've already arranged that. And then Artemis 3 is supposed to actually land humans on the surface. And we'll be back on the moon if all goes to plan. So SpaceX Starship has already been tested extensively, and it has reusable components. But the SLS, which was part of the plan, hadn't actually been tested before last Thursday. And so as far as I know, everything went according to what they were hoping. But this first actual launch is a bit nail-biting because the SLS, unlike the Starship, it doesn't have those reusable components. So it is more expensive, and it is riskier because, of course, we've we've never tried launching this vehicle before. So, very, very interesting time in space exploration right now, because of course Artemis 1, 2, and 3 is just the start. There's the Lunar Gateway, which is going to be a moon orbiting space station that we want to build, and making sort of a permanent moon colony. It actually seems like something we might be able to do. So I find it very, very exciting times, and you might remember just a few weeks ago, at least I think it was a few weeks ago, we had that accidental rocket booster crash on the moon, which started all that really good conversation about what are we actually allowed to do on the moon once we get there. We were talking about this before, is, what kind of legal agreements have we agreed to? Who's allowed to mine on the moon? Who's allowed to build on the moon? If all of a sudden the Earth-facing side of the moon had like highways and cities on it, what would that mean? Because it would literally affect every single person on Earth. So there's all kinds of really interesting conversations you can have about this. But the SLS has been rolled out, and it has been initially tested, if not actually launched. So that's mostly what I was going for.
I just had a thought, and stay with me, because so you mentioned like, okay, what if like the side of the moon that's facing us had like highways and all this stuff, and then so I was like, well, no, what if it ends up looking like, when you see those like satellite images of the Earth at night, right?
Yeah.
And you can see all the light and stuff. And I'm like, but like culturally, the moon is so important. Like,
should we even be allowed to build on the Earth-facing side of the moon? Should that be unallowed?
This is a fascinating debate topic.
I know, right? We probably won't be able to solve it.
Symposium on this.
If you want to start an argument between...
I don't want to start an argument, but I think it would be a fascinating, like...
Yes. Well, and it's a discussion that we need to have, right? Because you're never going to get all of humanity to agree. But we do need to come to some sort of accord so that somebody doesn't go and make a giant like Pepsi logo on the Earth-facing side of the moon, right? That would be awful. that would be absolutely terrible. So we definitely shouldn't allow that. But
it more likely would be a SpaceX logo, but whatever.
Yeah, that also probably shouldn't be allowed. So
I agree. That was my my sarcastic voice.
Space law fans, do not email us. This is we are. I am definitely not in favor of any logos on the Earth-facing side of the moon. I think that would be in very bad taste.
Frankly, any side of the moon.
Yeah.
Yeah. I don't. Yeah. Oh, that's a fun one to. It's going to be a fun one to like bounce around a bit.
Yeah, bring your lawyer and the science fiction writer, and we'll need an economist and a physicist and a biologist, and we'll get them all in one room and we'll solve it.
Sounds good.
All right.
Sounds good. All right. A footnote to this Artemis and SLS testing. Before we came on air, I did a quick jump over to Universe Today, and the second article that was there was about Eddie Vedder providing music for an SLS video. And here's the thing about me. In the early 90s, I wore much plaid. And so I'm like, Eddie Vedder? So if you too are an Eddie Vedder fan, point your browser to YouTube and, search up Invincible by Eddie Vedder, and you will find a NASA video with a song by Eddie Vedder and some NASA imagery and some other things.
Hey, who doesn't love a good astronomy song?
Yeah.
That sounds awesome. All right. Shall we go onwards and upwards? So what's past the moon?
What's past the moon is a beautiful, beautiful telescope known as the James Webb Telescope. That is 2 more steps closer to being aligned. And so a new engineering image has been released of the star 2 mass J17554042 plus 6551277, because we're good at naming things.
I have it as HD 84406, but yeah, we are awesome at naming things.
We are awesome at naming things and giving them more than one name, and the both names being equally as forgettable. And it looks like the optical performance is even better than the most optimistic predictions have been. The image shows that the 18 mirror segments are precisely aligned and are now acting as one giant high-precision 6.5 meter primary telescope mirror. Woohoo! Mm-hmm. The diffraction-limited alignment of the telescope has been achieved. The mirrors are focused together as finely as physics will allow. And this is the sharpest image that you can get from a telescope this size. Fantastic. In the background of the image, you can see galaxies. It looks much like HST deep field images. It's one of the quotes in the article I read was, "Everywhere is a deep field." Like,
yeah,
great,
yeah.
Fantastic.
It's amazing. It really is awesome. So if you haven't had a chance to see it, you will know it right away by the abundance of galaxies.
It's very pretty. They experienced no issues with any of the deployments, so that's fantastic. So the two steps were steps 4 and 5 of the seven-step, 3-month-long process, and they've now been completed. The image was a 2,100 second long exposure that would allow them to test several aspects of the telescope's performance. The optics are working perfectly. Other systems are working fine. Guidance sensors, reaction wheels that are important for precision pointing and staying on target, all great. The star was chosen because it's, quote, generic, anonymous, average, and faint. It's 100 times fainter than what the human eye can see, but it looks super bright in this image. And it's all going awesome. And now the next step is to start testing the instruments. And by the end of June, everything should be set up and ready for science. There's still some instrumentation that still has to cool down, but we're all well on our way.
Yeah, cooling down to just a few degrees above absolute zero. This is such an amazing telescope. And of course, the 6.5 meters puts our campus telescope to shame. But the real way they're winning is by being outside of the atmosphere and away from any kind of heat influence from the sun, being on that other side of the moon with the heat shield. They've eliminated so many sources of error. I'm not surprised that they're getting amazing images already. It is, I believe, in the milli-arc second resolution. For those of you who are familiar with astronomy, the moon is half a degree, so this is really, really, really small objects that we're able to actually see the sizes of. They don't just look like blurry points of light.
It's gonna be fantastic. On that, thank you for listening tonight. Stay tuned. Quirks and Quarks, Western World, Science for the People.
AFM Radio.
Good night, everyone.
Good night.
This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is astronomy.fm radio.
AFM. This is a CBC podcast.
T-minus 10, 9, 8, 7, 6.
E is equal mc squared, in which energy is all steps per man.
The human genome is our shared inheritance, and it is fitting and proper.
Cracks and cracks.
Hi, I'm Bob McDonald. On this week's show, There She Blows. A scientist channels his inner Ahab to measure a blue whale's heartbeat.
What we'll do is attach a platform to the front of the boat that I stand on with